So I have been working at Google for last 6 years, and for last 4 years, I have been working as a developer advocate for Google Cloud Platform. And now I'm focusing on the big data projects and machine learning projects such as Google BigQuery or TensorFlow and machine learning APIs. Today, I'd like to quickly cover those topics. What is neural networks and deep learning with live demonstrations, the live real working neural networks in the browser. I will discuss how Google has been using the machine learning and deep learning technologies for implementing our services. And in the latter part, I'll be discussing how. Okay. How the external developers and customers can utilize the power of the machine learning developed by Google. So what is neural networks and deep learning? You can think that neural network is just a function as in mathematics or a function in a programming language. So you can put any kind of data as an input and convert all the data into the vector. For example, if you have an image of a cat, you can try to convert the pixel data into a large vector and do the massive matrix operations inside the neural networks. And eventually you would have another large vector which has the cat as a label as a result. And you can apply these technologies to any kind of the applications. For example, you can use the neural networks for the voice recognition or text processing or any other kind of applications, including the user activity analysis in the gaming or the ads analytics, anything. So let's take a look at how neural networks can be trained to learn the data patterns inside the training data set by using these double spiral patterns. So if you take a look at these patterns, you can decide which takes two inputs, the one input and the second input. And if you plot the data points with those inputs, you can easily find there's two different groups of the data points. One is the orange group and the blue group. And for humans, it's really easy to understand the pattern inside this data set. So, for example, if you have a new data point here, you can easily tell that this must be belonging to a blue group, or the new data point here must be in the orange group. But how can you instruct the computer to classify those data points? So this is where you can start using the neural networks and machine learning technologies. This is a demonstration called Playground, where you can actually build your own deep neural network model inside browser, and you can tweak all the configurations, such as how many neurons in each layer, or how many hidden layers, or what kind of the activation function you want to use to train the model.
Kaz, sorry, didn't mean to interrupt. Can you guys hear him at the back? Or do you want him to use a different mic? Do you want him to use a different mic?
Okay, should I stop? Okay. Hello? Okay, yeah, this is much better. So I will start training the model. Now, we have started training the neural network model, where we have two inputs here, x1 and x2, and you have the output neuron here. This single neurons predicts whether a data points will be in the orange group or blue group. And initially, the neural networks doesn't make any sense whether the points is in the orange or blue. But if you keep telling the neural network that this must be a blue or this must be an orange, then gradually the neural networks can understand what's the patterns embedded in this training data set. So now you are seeing that the neural networks is fully trained, and it's not so great. Maybe I can try it. Yeah, sometimes it's not sometimes. Many times you would see the trainings of the neural networks fails. So you have to have bunch of computers running on the Google Cloud to try out the trainings process. But eventually you would find the best of the training result in the neural networks. So here you go. You can see the neural networks can find out what will be the patterns embedded inside the neural networks. And if you take a look at what each neurons are doing inside these deep neural networks, then you can find that each neurons is doing a very simple classification like this. these neurons at the top left corner only classifies whether each data point is in the white place or blue place. Again, these neurons checks whether the data point is in the upper layer or lower layer. But the neurons inside the second layer can take all the outputs from the first layer and combine all the results to compose a new data patterns to recognize, like this. So neurons can be much smarter than the neurons in the first layer. So neurons in the third layer can capture much more complex pattern like this. And the final neurons in the output layer can recognize the complex double spiral, just like humans. And the more important thing here is that you don't have to instruct the computer what kind of the data pattern you have to recognize. So all those patterns are automatically generated by the neural networks, and you don't have to create those patterns. Computer can find those features, patterns of features, by taking many training data sets and extracting the features and patterns from training data sets. So neural network can extract the hidden features from data, and sometimes it can find the hidden features that is unknown for humans. So that's the reason why the AlphaGo AI, the AI-based Go player, was able to beat the top class champion Go players. And now we have the latest version of the AlphaGo, which is called Master, which has been winning the up to what's that? Which is now winning for the last 40 matches for the Go player with the top champions. So by using these technologies, you can have computers recognize this particular image as a cat or the pet or the British short hair. And to do that, you have to have the so-called deep neural networks. And in the demonstrations I've shown, we use the 3 hidden layers between the input data and the output data. But in this case, you have to have more and more layers, like 40 layers or 50 layers. And sometimes we have over 100 layers between input data and the output data, so that the deep neural networks can be trained to recognize from the very simplest patterns on edges like this, or a little bit complex pattern like textures, or a part of the objects in the images, or a whole object in the image like a human face, or mountain, or car. So that's the very basic of the deep neural networks and machine learning, and how Google has been using these technologies for implementing Google services. For example, Google Search Service has deployed a new algorithm called RankBrain in 2015, last 2 years, that provides the ranking, that defines the ranking of this Google search result. And RankBrain is the best improvement we had in last 2 years in the Google search team. So you can say that almost all Google services, users of Google services, has been using the deep learning every day. Google Photos is a smartphone application that lets you understand the contents of the images. So you don't have to put any metadata or tag on images. Instead, the deep neural network model inside Google Photos can recognize an image content of the images, such as dog or the wedding party or anything, or your friends, family. Smart reply feature in the inbox can generate the options for replying the email by taking a look at the context of the email exchanges. And now the 10% of the all responses sent on mobile are now generated by the smart reply feature. So you can say that now a major part of the emails are generated by AIs, not by humans. And people are just authorizing it, sending the content. Google Translate service recently had a major change on the underlying model, which is called neural machine translations. That uses so-called end-to-end translations. So if you put the English sentence on the service tries to find the best sentences in the target languages, such as Korean or Japanese, that represents the most closest meaning of the sentences, rather than analyzing the phrases and syntaxes in the sentences. And it provides much better quality, especially the fluency is much better. So the Google Translate service still makes a mistake on the translating, But the huge difference is that it's so fluent on making mistakes. So it's so confident even when it's making a mistakes on the translations. So you can try that to find that. DeepMind team who built the AlphaGo AI recently announced a new algorithms called WaveNet, which is a voice synthesis algorithms by using the convolutional neural network model. So I can show some demonstrations of the network. So if you go to the blog post about WaveNet, you can find some very interesting samples of the synthesized voices. So at first, I'd like to play the synthesized voice by the existing model.
The Blue Lagoon is a 1980 American romance and adventure film directed by Randall Kleiser.
So this was the quality by the existing model, and by WaveNet.
The Blue Lagoon is a 1980 American romance and adventure film directed by Randall Kleiser.
So it's much, much better. So if you take a look at the quantitative measurements, so this is the performance of the human speech, and WaveNet is much closer than the existing models. But what I'm so surprised to when I was reading the blog post was the result when you train the model with the classical piano music. So you can use exactly the same model to train the model with the piano music to have the neural networks to generate the classical piano music like this. So you can, as you heard, this is just on classical piano music, but this never existed. This is generated bit by bit from neural networks. So that means there's no copyright owner for this music. You can generate this kind of music infinitely without paying any copyright fee. And this is done by, not by sampling or just a duplication or copy of the existing music. This audio was generated bit by bit directly from the neural networks by training the model with the classical piano music. Google Brain team recently announced a new achievement on the application of the medical images analytics. So by having the deep neural networks analyzing the image of the human eye, then it can provide a much better result on the detection of the diabetic diseases, better than the average doctors. This is another very impressive result we had with the DeepMind team. DeepMind team had another deep neural network model that tries to optimize the cooling resource energy usage in our data centers. And the result is that we were able to improve the PUE up to 15%. And Google is not publishing the exact amount of the money we are spending for the cooling energy or the power consumption for the data centers, but it's not a small amount of money. You can save the 50% of that amount by turning on the machine learning. So now we have over, I think latest number is over 100 production projects inside Google that has been actually using the deep neural network model, not only the traditional machine learning models. And now we are trying to externalize this power of the machine learning developed by Google to be able to utilized by the external developers and customers. We provide two different kinds of products. The first product is called ML API, which is designed to be used by every developers who doesn't have any machine learning expertise and knowledge. So you can just send your images, audio, and text to the API, and you'll be getting the result in a couple of seconds. The other products is designed for the data scientist or the engineer who has the knowledge about machine learning, which is customizable for any kind of the applications. We provide the platforms and libraries for those customizable model. Let's take a look at the machine learning APIs. The first product is called Cloud Vision API, which provides the pre-trained model for the image analytics. You don't have to have any ML skill set. So you can just send your images to the cloud, and that's it. Let's take a look at the demonstration. This is a demonstration called Cloud Vision Explorer. which has 80,000 images uploaded to the cloud, and we have applied the Vision API analytics to all of those images. And by using the result getting from the APIs, such as a label, such as cat, or human face, or automobile, vehicle, we did a clustering analysis. So what you are seeing right now is a 3D space where you have the multiple cluster of the similar images. So here you have the cluster for the vehicle images, and if you take a closer look at the thumbnails of each images, the actual thumbnails of the images are popping up like this, and it looks like it's a cluster of the airplanes. If you click one of these, then you can see what would be the result of the API analytics. For example, if you send this particular image to the API, you'll be receiving labels such as airplane, vehicle, or 747. And if you send the cat images I have shown, then the API can return the results such as cat or pet, or it must be a British short hair. It can also detect the location of the human faces like this. Although the API doesn't provide any personal identification features, but it can locate the places of the eyes and nose and mouth and direction of the head in 3D space. And also it can detect the emotions of each face, like whether it has the joy emotion, or sorrow, or anger, or surprise. And also it has the so-called landmark detection feature. So if you send a picture with a very popular place like this, then API can detect where it is. So API thinks this image must be in Citi Field Stadium in New York City with the coordinates like longitude and latitude. And I want to show another interesting demonstration of Vision API, which is this robot. This is actually a Raspberry Pi based robot car. It's a commodity product sold by Dexter Industries. And what I have done with this demonstration is I have written about 50 lines of Python code in my weekend times that takes an image from the camera and send the image to the API so that the robot can understand where are the people faces and what are the objects it is seeing. So let's turn on the, can I have the microphone? Yeah.
It's night.
So if you put any
It's street light.
not street light.
It's atmosphere on Earth. It's morning. It's flower.
It's flower.
It's petal.
It's petal. How about
It's
this?
plant. It's atmosphere on Earth.
What is this? Maybe I should be.
It's glasses.
It's glasses. What is this? If you have the
It's glasses.
glasses, sometimes if you have the busy background, it's really hard for him to understand. What is this?
It's car.
It's car, yeah. And it also has
It's
the
sports.
wow. Yeah, this is what I wanted to demonstrate. It's designed to follow a smiley faces. So, but to do that demonstrations, you have to keep your smile face for a while, like this.
It's image. Hello.
Hello? Yeah, it follows the smiley faces. So that was the demonstration, thank you. Oh, sorry. And there's some other interesting APIs that provides the pre-trained model for voice recognition and natural language processing, such as this. So let me try the live demonstration again. Also, I have my English accent, but API tries to understand my English voice. Hello, this is a demonstration of the Google's machine learning technology. Yeah. Yeah, sometimes this is maybe because of my accent. But still, you saw the response. It's supports both the real-time recognition and the batch processing. And if you use the real-time recognition, you can get the result in like a 0.5 seconds. It's pretty fast. And we use exactly the same voice recognition used for the Android devices and put an API for that. And you can use the recognized text for testing the natural language API. It's not curious. Yes. Google's. So if you have a call center in your business, you can record all the dialogues between the operators and customers and try to use the speech API to convert the voices into the text and use the natural language API to analyze the meanings of the content, the dialogue, like extracting the entities, name of the products inside the conversations. And you can also do the sentiment analysis, whether the sentiment means anything positive or negative. And also you can easily do the syntactic analysis. You can take out all the tokens or words, part of speech for each sentence and understand what's the dependency between the part of speeches. So you can easily analyze the natural language by using the API to understand the real meaning of the customer's voice or any natural language. So those are the machine learning APIs. And all of those APIs provide a pre-trained model, so you don't have to train your own neural network model from scratch. But instead, there's some downside of using those ML APIs, which is the customizations. What if you want to analyze medical images taken from the CT or MRI to find the cancer? You cannot use Vision API for that kind of the purposes. So for those kind of the customizable machine learning applications, we recommend to take a look at the TensorFlow, which is an open source library for machine intelligence. Doesn't work. Okay. So TensorFlow is the open source library developed by Google, and we have launched the product in November 2015. You can download the TensorFlow from the tensorflow.org, and this is the latest machine learning framework we are using inside Google, used by all the latest AI researchers and machine learning developers inside Google. And now the TensorFlow is the most popular deep learning and machine learning product published on GitHub. For many years we had many popular open source tools such as Theano or Caffe or Torch, but TensorFlow has much bigger popularity right now because it's really easy to use. It's much better than the other products. You can just write tens of lines of Python code to define your neural network model like this. If you have a single layer of the neural networks, you can just write 10 lines of Python code to define that. And also another important part is that you can reuse the existing optimizing algorithms implemented by the Google engineers, just like this. So you don't have to have a skill set to implement your own latest optimization algorithms such as gradient descent or AdaGrad or ADAM. You can just specify what kind of the algorithms you want to train the model. And another very important aspect of TensorFlow is the portability and scalability. So once you have tried out TensorFlow by using your Mac or Windows, you will find that the deep neural networks consume so much computing power, so you may want to buy a GPU server to run the training, but that is not enough. Usually you have to use multiple GPU servers running in parallel to do the distributed training. So that's where you may want to upload your model or neural network design to on the cloud, where we have tens of thousands of GPU servers. So you can just rent tens of GPU servers only for maybe 30 minutes or 1 hour to have the large scale distributed training with TensorFlow. TensorFlow is designed to distribute your workload into the bunch of the different GPU servers automatically. And once you have finished your training with deep neural networks, you can copy the model onto the smartphones or embedded devices such as Android, iOS, or Raspberry Pi. And still you can keep using TensorFlow as a framework. So you don't have to build your own framework or toolings to train the model and deploy the model into those clients and embedded systems. Recently, Qualcomm made an interesting announcement about the support of TensorFlow on the Snapdragon chipset. Now the DSPs, the digital signal processors in the Snapdragon chipset, supports the TensorFlow natively. So I can show the demonstration video. Yeah, if you go to the blog post published by the Snapchat, no, not Snapchat, Qualcomm, then you can see there's a demonstration of the difference between the TensorFlow supported DSP and CPU. If you use the CPU running on the mobile phones to do the deep neural network recognition and image analytics, it would take only, it would usually takes a couple of seconds, like 1 second or 2 seconds to recognize a single object. And it also consumes much power and battery. But if you use the DSP in the Snapdragon chipset, which is natively supporting the TensorFlow, then you can shorten the latency into 100 milliseconds or maybe less than 200. It's 10 times or 20 times faster. And also, the power consumption is much, much lower. So now, it's much, much easier to embed the deep neural network prediction model embedded in your own production smart applications. Okay, so that's the power of the TensorFlow. And by using this power of TensorFlow, very interesting thing is happening in last 6 or 12 months, which I called a democratization of deep learning. Just like these cucumber farmers in Japan. There are cucumber farmers in Japan, and they have a son called, his name is Makoto-san. And he was originally an embedded systems designer and a systems engineer, but he started helping out the cucumber farming by his parents since last 2 years. And he found out that sorting cucumbers is so tedious task. His mother has been spending 8 hours in a day to sorting out all the cucumbers based on its shapes and colors and lengths into 9 different classes. And he didn't want to inherit that kind of the tedious task. He didn't want to help that. So what he did was to build a cucumber sorter by using TensorFlow. So these are the cucumber images classified in the 9 different classes. And he bought some Arduino microprocessor and, oh, sorry. I think it's not connected to the internet. Why it's not playing? Yeah, here you go. So what he built is by using Arduino and Raspberry Pi. Maybe I can. Yeah, thank you. To build the prototype of the solder. So it takes a picture of the cucumber and classify the cucumber into 9 different classes. Just like this. And the important point to note here is that he didn't have any expertise on machine learning or deep learning at all. He just started learning machine learning and deep learning by downloading TensorFlow. And he only spent $1,500 to build this machine, and that's it. TensorFlow is open source, and there's no cost. But still, he was able to get with the initial trial, he was able to get up about 70% accuracy, and he's so sure that he can increase the accuracy into 90 or 95% by using the much more powerful computing resources. Another very funny use case is the fried chicken nugget server by TensorFlow. Can you lower the volume? Yeah. Oh, sorry about the noise. Yeah, I can mute the YouTube video. So the point here is that this is done by developed by the intern student in the company. So the company is a company for the robotics arm manufacturing, and they didn't have any expertise on deep learning or machine learning. But the intern student wanted to try out TensorFlow to control the robot arm, and he did it in 2 weeks by making the fried chickens by himself for hundreds of fried chickens, chicken nuggets, and taking photographs of those chicken nuggets and train the model to locate the position of the fried chicken. So I have plenty of the other very interesting use cases of the TensorFlow, but so I cannot play all the videos, but I can show some. For example, somebody made a garbage can which can sort out the garbages by using TensorFlow, whether it's recyclable or not. This is another very interesting use case of the neural network. This looks like the images of the girl faces, TV popster, but these are all non-real people. These are virtual girls. There's no existing people who has these faces. And this is, again, another very interesting use case of TensorFlow by an amateur developer who collected thousands of the images of the TV popster and girls from the internet, and he extracted the feature of those TV popsters. And by using the very interesting algorithm called GCGAN or GCGAN, you can extract the features and then generate a new images that has the exact same features, but still it can be a unique images. That means that new images is not the same as the in any one of the existing training data set. So that means, again, these faces doesn't have any copyright owners. It's copyright free. So you can generate any copyright free images infinitely by using GCGAN. The subsidiary of Sony Corporation in Japan is using the drones and TensorFlow for counting trucks in the construction site. And they are now also trying to counting materials such as how many steels and ladders and those materials in the construction site. So you don't have to have people counting all the materials and trucks and cars every day, whether any car is stolen or not. So those are all the interesting use cases of the TensorFlow happened in last 6 or 12 months. But the largest challenges for those interesting ideas and deep learning is the computing power that consumes. You have to spend so long times to finish your training with deep neural networks. People who are using the powerful GPU servers still have to wait a few days or a few weeks to finish your training. So that's the reason why Google has started to using the Google Cloud, computing power of the Google Cloud, to do the large-scale distributed training of the neural networks. In a single building of the Google data center, we have about tens of thousands of the servers. And the most different part of our Google Cloud is its networks. We have so many hardware engineers working in the United States. They are designing our own switch fabrics. We are not buying Cisco or Juniper routers. Instead, we are designing and building our own switch fabrics from scratch. Why we are spending so much investment on the building a switch? Because the network and latency is the key for building the scalable and successful big data solutions and AI solutions. So by using Jupyter networks that can host 100,000 ports of the 10 gigabit or 40 gigabit Ethernet that yields 1.2 petabit per second, you can consolidate all the server resources with microsecond latency, not the usual TCP/IP latency such as 500 microseconds or several hundred microseconds. You can say it as just a large-scale supercomputers working as a cloud with the thousands of nodes. And also we have developed the ASIC or LSI just for running TensorFlow, doing the massive amount of the multiplications between the matrices and vectors. By using this specialized hardware, you can get 10 times better performance per watt ratio compared with the existing CPU or GPU-based solution. And as a user, you don't have to think anything about those complex things running in the cloud. TensorFlow can take care of all the complex tasks such as how to having communications between the GPU servers, between the CPUs, and also when you are when you are doing the training of the neural network model, it is important to utilize the quantizations. That means compression of the parameters inside the hidden layers. And all of those optimizations for tolerancy is taken care by the runtime of the TensorFlow. And you don't have to hire a bunch of people who are knowledgeable about building the large-scale GPU cluster with the InfiniBand quantization for tolerancy. No, you don't have to spend that kind of money. And end result is much faster training times. So, for example, if you're running TensorFlow on Google Cloud, you can have 50 GPUs running for training a single model for the image recognition that can provide 40 times better performance. And for RankBrain, they are using 500 nodes for having a 300 better performance. So while people are waiting a few days or a few weeks to finish their training for neural network model, in Google engineers can spend only tens of minutes, like while they are going to lunch and going back to the office, his training is finished. So this is the largest difference between Google and other companies. And that makes us able to deploy the technology in the many different production projects, over 100 projects. And now we are externalizing the technology to external developers with the product called Google Cloud Machine Learning, or Cloud ML. So all you have to do is just define your own TensorFlow graph, customized for your own application, and upload it to the cloud. So we provide the pool of the GPU servers and CPU servers that provides distributed training and prediction. And lastly, I'd like to show a very unique use case of the Cloud ML by Oknet. Oknet is a real-time, largest real-time car auction service in Japan who has 30,000 used car dealers as members. But the problem for them is it's so tedious for the used car dealers for uploading all the images taken for each cars and classifying whether classifying the parts of car for each photos and car model. So solution they have chosen is to build the custom image classifier by using TensorFlow and Cloud ML. So let's take a look at the demonstration. So this is the system. So you can upload the image of cars. Like this. You have to take 20 different pictures of a car from different angle and also the parts. But by using this customized image classifier, the used car dealers don't have to identify those different parts of cars or car model. Everything is done by the deep neural network model. Now it's coming. Yeah. Here you go. So you can see that the system thinks that the car must be a Land Cruiser Toyota with an exact car model with the estimated price range. So for example, if you have a gas station and you can put the digital signage there with the camera, that shows, if you sell your car right now, you could get $1,000 or something like that. And also you can tell that, you can see, you don't have to specify what kind part of the car or what side of the car you are taking with the photos. The systems can tell the very subtle difference between the front seat and rear seat at a very high accuracy. So that can reduce the significant amount the operation times for the humans. And also another global insurance company called AXA in France is now trying out the TensorFlow for finding the large loss cases in car insurance. Large loss means the drivers who would have the serious large car accidents that requires over $10,000 for as a car insurance payment. By using the TensorFlow model, they were able to achieve almost double, twice accuracy on forecasting the large loss cases. So in summary, we are providing two different products. One is the ML APIs that could be used by non-machine learning engineers easily. And another set of products is designed for the data scientists or the machine learning engineers. That is customizable for each different applications. And also it is scalable with the tens of GPUs and CPU servers running on Google Cloud. But you don't have to build your own GPU cluster by yourself. So that was my presentation. Thank you so much.